Okay, hello, logicians. This is my first screencast, so forgive me if I sound amateur. Um, Before we go to the homework due upcoming, uh, last week I didn't go over that final problem in that group, and so I'll do it this time just as a demonstration of how to solve yet another proof. And the steps should be familiar to you or becoming familiar. All right, so here's our proof and this conclusion here. Don't worry about the operator. Just start with the letter that makes up the conclusion. And we have here the letter K. And the first question to ask yourself is, where among the premises do you see that same letter K? And up here in this first line, premise number one, we see the letter K. And it's the only place where the letter K occurs. So that means that conclusion ultimately must come out of line number one. That's the first step. Second step is ask yourself, what do the premises share in common with one another? And we see this letter J in common, and also this J over here in common. So that's another clue. Now, what strategy might we use to get the K from line number one, ultimately to get it out? Now, there's no rule that lets you pluck a K that's embedded already in a chunk. Notice that we have main operator wedge in line number one, and then to the right of that main operator is this parentheses enclosed chunk, which has K in it. There's no rule that will let you just pluck it out of that embedded chunk. And you can look here at the rules, and you see there's no rule that fits that form where it's P wedge and then in parentheses say Q horseshoe R. There's nothing that looks exactly like that that lets us just pluck that chunk on the left side of this horseshoe embedded in this chunk on the right side of the main operator wedge. That doesn't exist. So what we will do is use a strategy where we gradually refine it out, or gradually we pull it out in chunks and pieces. See, like, oh, there, see, there's a babushka doll, right, where you got a doll inside of a doll inside of a doll. Wait, I had another thing to, oh, wait, oh, well, I thought I had another thing to show you. Anyways, you get the idea, right? There's a doll inside of a doll inside of a doll. So if you wanted to get this doll, first you'd have to open these other ones. Okay, you get where I'm going with that. So as a first step, let's see if we can figure out some rule that will let us get this chunk, the whole chunk with K in it, out of line number one and isolate it by itself on a new line. In other words, somehow from line number one, we would get as offspring, we can't get K right away, but maybe we can get the K horseshoe J, that whole chunk, get that chunk out of line number one as an offspring. And then once we have that isolated, then we can try to get the K from there. So if we're going to use a rule, we have to find one where the parent in that rule has main operator wedge. With no point in looking for a rule that has main operator horseshoe, because this parent on line number one doesn't have a horseshoe, it has a wedge. So we're looking for a rule. We're looking for a rule where the parent in the blueprint for that rule has main operator wedge. And so not that one, because that has horseshoe, not modus ponens, that has horseshoe in it, not modus tollens, that has horseshoe in it, not hypothetical syllogism, lots of horseshoes. Disjunctive syllogism. Here we have a wedge as main operator for the one parent. And then notice that this chunk on the right side that's labeled Q, this chunk is what we get to take as an offspring. Let's see if I can mark this up. So here is the chunk Q on the right side of that wedge, that's what we get to take as an offspring. Nice. Okay. So that seems to fit the bill, at least this first part of it. So that means when we go back to look at that parent on line number 1 in the proof, we want to correspond it first to this blueprint, P wedge Q. Let's see if we can correspond it to P wedge Q. So here's main operator wedge. Everything to the left of the wedge, we're going to call that P to correspond to that blueprint. And then everything to the right of the main operator wedge, all of that has to be Q. There we go. So we have something on line 1 which can correspond to P wedge Q, can correspond to this rule here, disjunctive syllogism, P wedge Q. All right, we got a match. So that's good. And then the second parent for that rule is whatever we were calling P, that same chunk for the second parent, but with a tilde in front of it. So what did we assign to P when we corresponded the first parent to P wedge Q? We assigned this chunk J. And look, here on line 2, we got that same chunk J. So here I'll call it P. P. We got that same chunk, doesn't look very good. There. We got that same chunk J, so we can label it with the same label P, but it has a tilde in front of it. So that exactly matches here, this tilde P. Aha, all right, so we got a perfect match. The first parent can correspond to P horseshoe Q. The second parent, we can make it correspond to tilde P, whatever we were calling P up here, same chunk. So we got an exact match. All systems go. Now we can, see if I can get rid of that. Now we can apply the rule, because we got all the parents in place and we can apply the rule. So that means the offspring, remember the offspring by disjunctive syllogism is whatever's on the right side of that main operator wedge, in this case K horseshoe J, all of that becomes the offspring, K horseshoe J, and we got that offspring from line number 1, and the parent on, so parent on line number, premise, whatever, line number 1, parent, premise on line number 2, and the rule is disjunctive syllogism. Green light. All right, all systems go. Looks good. So now we've isolated that chunk that had K in it. Now we've got it on a line by itself, and that K is hanging out exposed over there on the left side of the main op. Now we got a main operator horseshoe, and hopefully now we can pluck it off from the parent on line number 3, where it stands on the left side of that main operator horseshoe, and we can put it on a line by itself, and fingers crossed we'll pick up a tilde along the way. Hopefully we'll get a rule that does exactly that. So, okay, this is the chunk we want, the K. We want that, and hopefully we'll pick up a tilde. And it's on the left side of a main operator horseshoe. So now we're going to look for a rule that has a horseshoe as main operator for the parent. And the offspring for that rule will be whatever rule it is that we hope we can find. The offspring is going to be that same chunk K, but with a tilde on it. So let's see if we find something that matches that. Not modus ponens, because notice the offspring is a chunk on the right side becomes the offspring, and it does not pick up a tilde. Modus tollens, hey, look, we got a horseshoe's main operator for the one parent. This chunk on the left side of the main operator horseshoe, that chunk that's labeled P, that becomes the offspring, and we pick up a tilde. Perfect! It's exactly what we want. So this time we are thinking of this chunk to the left of the main operator horseshoe as corresponding to the label P in the blueprint for the rule. This chunk to the right of the main operator horseshoe corresponds to the label Q, in the blueprint for the rule. So we've got now something on line number 3 that corresponds to P horseshoe Q, which matches up to modus tollens here, P horseshoe Q, that first parent from modus tollens. Perfect. But notice modus tollens requires a second parent that here has the form tilde Q. So that means whatever we were calling Q up here, that same chunk is down here, the second parent, but it has a tilde in front of it. So let's see if we can find something. So we were calling J here on line number 3. J corresponds to Q. So the second parent would need to be that same chunk J, but with a tilde in front of it. Wait a minute, I remember we looked for something like that before and found it on line number 2. So look, on line number 2, we've got something J, the same chunk J. So because it's the same chunk, we can give it the same label, but with a tilde in front of it. So we've got here something that corresponds to tilde Q, and remember we assigned a meaning to Q at this step, line number 3, where we assigned Q to the chunk J. So we have something of the form tilde Q, and here we have something of the form P horseshoe Q. So now we've got two parents. We've made them exactly match the blueprint for the rule modus tollens, right? P horseshoe Q, second parent tilde Q. And remember, it doesn't have to be in that order with the horseshoe parent first and the tilde chunk parent second. It can be in any order, and in this case, it is. We have this chunk occurring first, and that chunk. It doesn't matter the order; it just matters that we have the complete set. All right, so we've got everything we need, which means we can get as an offspring by modus tollens the chunk, whatever we were calling P. That gets to be the offspring, and we pick up a tilde, and that's exactly what we want. So in other words, the chunk we were calling P on line number 3, K, that becomes the offspring, and we get to pick up a tilde along the way. So tilde K from parents 2 and 3, and the rule is modus tollens. Check. Got a green light. So now we have exactly, on line number 4, we have exactly the conclusion, tilde K, tilde K. That means we have accomplished proving that tilde K follows from those premises. And if I hit check proof, I get my points here, +2. Okay.